A particle scattered by a central potential Vfr equal to V naught or e exponential of minus mu r, where V naught and mu are positive constants. The momentum transfer Q is such that Q much greater than mu. The scattering cross section and the Born approximation as Q goes to infinity depends on Qs. They are asking what order of it is depend on the Q, the exponential, the power exponent of the Q. If you want to calculate the scattering cross section, first we have to evaluate the what is the scattering amplitude for the given potential. The particle will scatter that much amplitude for the given potential. For that purpose, we are going to use this formula. The scattering amplitude f of theta comma pi should be equal to minus 2m divided by h gut square q integral 0 to infinity or sin q or this argument dot v of r dot dr. So minus 2m h gut square q integral 0 to infinity. We are going to substitute the potential where the particle experiences scattering. That potential they are given v of r equal to v naught into r exponential of mu r. So that potentially we are substituting here. The remaining terms as it is. We can take v naught out. So minus 2m v naught divided by h gut square q integral 0 to infinity r into r square. The sine q of, if you are modifying this one, exponential of iqr minus exponential of minus iqr divided by 2i. This whole value is sine qr into exponential of minus mu or dot dr. If you are see the left hand side, not left hand side, the integration coefficients minus 2m v naught divided by h gut square q into, we can take this 2i out. So we can split this integration into two. The first integration integral 0 to infinity r square exponential of iqr into exponential of minus mu r. So iq minus mu into r dot dr. The center is minus, again integral 0 to infinity r square. Now multiply these two. Exponential of minus minus, take the common minus out, iq plus mu into r dot dr. Now we can use this formula. This is a known formula, even you can derive from by integrating by parts. So 0 to infinity t power n e to the power minus at dot dt equal to n factorial divided by a to the power n plus 1. That means the coefficient. Use the same formula for the both integration here inside the whole bracket. The front coefficient is minus 2m v naught divided by h gut square q into 2i. Use the factor here 2 square, so 2 factorial, the coefficients n plus 1, that means 2 plus 1 3, the coefficient iq minus mu. Same here 2 factorial, the coefficient time the whole to the power n plus 1, that means 2 plus 1, that is 3, minus iq minus mu, that is the coefficient, whole power 3. Exactly here n factorial, here 2 factorial, both of them. Then we are taking a power n plus 1, we are taking the coefficient power n plus 1, that means 2 plus 1 3 3. Take the 2, there are here also 2 1 2 common out. So if you are taking 2 common out, 2 to are 4 m v naught divided by 2 I h gut square q. Do the cross multiplication. If you are taking 2 out, here 1 will be there, so iq minus mu whole cube. If you are cross multiply, iq minus mu whole cube divided by, if you are multiply these two, here a plus b, a minus b, so a square minus b square whole cube. So I can keep the whole cube as it is. We know the a plus b whole square or whole cube, a minus b whole cube is equal to a square minus b square whole cube. Same way we are using here, same formula. So mu square minus iq whole square, but minus iq whole square is nothing but I square, it will come. So minus into minus plus q square whole cube. Now we are using this condition, mu is much less than q. So the denominator mu goes to 0. So q square into 3 q power 6. Outside one q is sitting here. Don't forget. Other things are constant. V naught, potential, mass, the Planck constants, everything is constant. I am the total value I am calling it as C dash, because we want to find the Q relation for the total scattering cross section. So 1 by Q. Here also we can remove the mu. So if you are minus IQ whole cube, IQ whole cube minus of IQ whole cube. So here minus IQ whole cube, here minus of IQ whole cube. If you are taking minus IQ whole cube, it will give Q cube plus minus of IQ whole cube, it will give plus I cube, because I square it will form 1 minus, so minus into minus plus. Then one more I sitting here, I cube whole square. Here also one I will come. So totally we can return as approximately the constant time 2I cube power 7, or else approximately C dash 2I cube power minus 4. The scattering cross section is equal to the scattering amplitude whole square. If you are taking whole square, no need of doing this time step. You can guess what it is from here. Already we found previous page q power minus 4. So sigma equal to q power minus 4 whole square. Some constant sitting outside. So sigma equal to c some constant time q power minus 8. So the scattering cross sections is related to the q value power of minus 8. Given option is 1.